Welcome back to Chapter 1, Introduction to Virtual Computing, Part 4. In this session I'll be discussing virtualization software features that you find in different products and described in pages 23 through 36 of your text. Let's start with hardware virtualization features on page 23. As we described earlier in this chapter, Hypervisor provides a virtual machine with a virtual motherboard, the chipset, virtual CPUs, memory, and so forth. And when configuring the number of CPUs for a virtual machine, it's best to start with a lower number and then slowly increase if more performance is needed. Another feature to look for is support for the new UEFI firmware. In addition to the older traditional BIOS firmware, some of the new hypervisors will support UEFI. Also, verify your hypervisor supports hardware virtualization. We talked a little bit about that earlier in the text. Remember, you need to turn this particular feature on with your host computer's BIOS. And finally, for better security, make sure that your hypervisor supports NXXD, Data Execution Prevention. This prevents a virtual machine from accessing another virtual machine's memory. Memory support features also that we want to be aware of. First of all is how much memory can the hypervisor support in the host computer. It's particularly important when you're dealing with type 1 hypervisors where you may want to support a terabyte of memory. Next, support for second level address translation as compared to software page tables. SLAT uses a CPU hardware feature which reduces the overall managing time of the software page table, so you'll get better performance with SLAT. Another support feature is ballooning. Ballooning forces a virtual machine to release unused memory. And then the support for overcommitment of memory. In other words, if you have hypervisor supports overcommitment, then the total amount of memory of your VMs is allowed to exceed the memory of the host. And in many cases, this is not a problem since each virtual machine will not be using all of its memory. And then, especially in type 1 hypervisors, take a look for page sharing and page compression. These can make quite a bit of difference in performance as well as memory utilization. Certain devices on host computers are single, they cannot be shared with machines at the same time, for example COM or LPT ports. And many hypervisors provide the ability to configure a virtual machine to use standard COM ports by bridging or capturing. In capturing, the data sent to the COM port, for example, or the printer port would actually go into a file to be looked at later. USB ports also are dedicated to a particular machine. So in order to use USB ports, your hypervisor has to be able to connect the host USB port to the virtual machine. And this is an optional feature, not found in all hypervisors. For example, Hyper-V in its current version does not support assigning the USB port of the host to a virtual machine. And this, of course, actually provides additional security, as sometimes viruses and malware can get into a computer through the USB port. And then we have CD or DVD devices, and also they can be mapped. You can map the physical DVD or CD to a virtual machine. Hypervisors also allow you to point the virtual machine CD device to an ISO file. And we'll be using that feature in order to install software on our virtual machines. There are two major types of consoles. You have the administrative console, which is used for management, like creating, removing virtual machines, configuring settings, managing virtual storage and networks, and so forth. Then the user console, which is a window to the desktop of the OS environment running on that virtual machine. And user consoles allow you to do things like pause the virtual machine, switch between devices, interact with the guest operating system. Consoles can either be GUI consoles, which are graphical user interface consoles, typically installed on the desktop of the host operating system, and they're most often found with Type 2 hypervisors, such as Oracle VirtualBox. as we see in this picture. The other type of console is a web-based console. These consoles are run from the browser, often used with Type 1 hypervisors such as vSphere, because they allow remote access and many features to be implemented at the browser without having to have a complex software interface at the hypervisor. Just support features on page 27 play a very important role in how your virtual machine accesses data. So the guest OS that's running is in this example in our virtual machine. We have a guest OS running Windows Server 2016, and the guest OS is using a driver for a SCSI connection. But as the guest makes requests of the hard drive, it goes through the hypervisor. Now the hypervisor is actually configured to use the hosts. In this case it's a PATA drive, and on that PATA drive there's a file which is the virtual disk drive. Now that file is going to be formatted in different ways. For example, VMware uses what's called VMDK format. But other hypervisors such as Oracle VirtualBox will use a different format here at the virtual disk image file, such as VDI. Microsoft Virtual PC uses VHD, and Hyper-V uses extension of that file system. So again, the guest operating system goes through its driver, which is a standard SCSI driver, to the hypervisor. The hypervisor then accesses that data on the virtual disk image file, which is using some other format for actual storage of data, which makes it very efficient for the hypervisor to get the data and then return it back through the virtual SCSI driver to the guest operating system. So the guest operating system doesn't have any idea really of what virtual disk format is being used. Virtual data can also be stored on network devices such as NAS or storage area networks. And we'll be taking a look at using SANs and NAS in chapters 7 and 8. There are two major types of virtual disk image files. First is a fixed disk image file type. In this case, the hypervisor creates a file on the host computer that takes up exactly the amount of space that you requested. This provides better performance as the space is pre-reserved on the hard drive, and it's often used with Type 1 hypervisors in production environments. The second disk image type is a dynamic one. In this case, the virtual disk on the host computer takes up only the space needed. You basically set a maximum size, and then as the disk space is used, it is continued to increase. This is not quite as efficient as the fixed disk, but much more flexible and is commonly used on most hypervisors. Another important feature of virtualization is being able to save a virtual machine state. And there are two common ways to do this. First is called a non-persistent disk. In this case, any changes made to that virtual disk image are only used during that session. And then when the session ends, the virtual disk image is put back to its original state. This can often be used when you want to share desktop, such as in a virtual desktop environment. Another way to save the virtual machine state is through snapshots. This allows you to take a picture, if you will, of a specific condition of your virtual machine, and then you can return to it later. Here we have an example of VMware's Snapshot Manager. This graphical user console interface allows you to see your current setting, as well as take a snapshot or return to existing snapshots. Parenting and cloning is a method to create a virtual machine, which we call a linked clone, from a master or parent copy. This saves time as well as disk space. Templates are another method to rapidly deploy fully configured virtual machines from a master. You will get to work with both templates and parenting in later chapters. it's often necessary to move virtual machines from one host to another. If you're using the same hypervisor on both hosts, just basically a matter of copying the virtual disk image file from one host to another, or possibly sharing them on a network drive. However, if you're moving virtual machines between different hypervisors, this will require some compatible format. A common format that's often used for this purpose is Open Virtualization Format, or OVF. Using OVF, you can export a virtual machine from one environment, such as VMware, then import it into another environment, such as Hyper-V or Oracle VirtualBox. VMware also has a virtualization capability, which is designed to work with their vSphere Type 1 hypervisors. This is called vMotion. With vMotion, a virtual machine can be moved from one host in the cluster to another automatically to support load balancing and disaster recovery. On page 33, we talk about network support for virtual machines. A host can have multiple network adapters for speed and fault tolerance, and then the virtual machine can be configured through its virtual network adapter to use one of these physical NICs. And virtual machines can have multiple virtual adapters. There's a few different ways in which these adapters can be configured. The first method shown here for VM1 is what's called a bridged mode. Here VM1 has direct access to the NIC through the hypervisor. This is often discouraged in testing environments for security reasons. Next, VM2 is showing what's called host-only mode. In this mode, the virtual machine only can access other virtual machines running on the same host. And then VM3 is showing an example of NAT mode. In NAT mode, the virtual machine accesses the physical network through the hypervisor. Hypervisor is acting as a NAT router. This increases security for the virtual machine and provides better control of its functioning on the network. We'll be working with these three different modes in later chapters. Migration tools are used to transfer traditional computer environments into virtual machines, such as transferring a physical computer into a VM format. VMware has a product called Converter, and this allows you to take a physical computer environment and it will build a disk image file for you, and there is a free download available to do that on single machines. And then Microsoft has a Disk to VHD as well as Virtual Machine Converter options that will do a similar thing. And then Microsoft Azure allows you to take existing systems, either virtual machines or physical systems, and move them up to the cloud. Table 1-5 on page 35 shows additional options for virtual machines. Things like shared folders, mouse and keyboard integration, time synchronization, drag and drop, and so forth. You'll have the opportunity to work with these options in later chapters. Well, that brings us to the end of Chapter 1 Concepts. Time to take a well-deserved break, and I'll discuss Chapter 1 activities in our next session.